Okay, moving on to example 2, and in this case these are broken down as limits where a hole exists. So I'm going to tell you to begin with that there's a hole here. So we're going to start by doing direct substitution. And when I plug in a 4, I get 16 minus 8 divided by 16 minus 40 plus 24, which is 0 divided by 0. And this has a special name. This is what's called can't spell today. This is called indeterminate. We cannot determine what that means. 0 divided by 0 does not mean anything. It doesn't mean undefined. It doesn't mean infinity. It doesn't mean 0. It doesn't mean anything. It's indeterminable what that is. So from there, what we need to do is we need to try a few different methods. And the method that we're going to work on today is factoring. So we're going to factor this. So this limit as x approaches 4, the top factors to be x minus 4, x plus 2, and the bottom factors to be x minus 6, x minus 4. And what you'll notice is we have a hole because the factor is in top and bottom of x minus 4. So this would be the exact same thing as the limit as x approaches 4 of x plus 2 over x minus 6. All right, before we move on, let's look at what that looks like graphically. So whatever this looks like, I don't know what it's going to look like, but I know that at 4, we have a hole. So let's just pretend that the graph is coming here. There's a hole going through. So what that means is the limit, as we're getting closer and closer and closer to that spot, would be the same as this function as if that hole was there. So what we're doing is we're removing the hole from this equation and then finding the limit likewise if it wasn't even there. Okay, so what we're going to do is we're going to do another direct substitution. After we cancel anything out, we try again. So when we plug in a 4, we get 6 over negative 2, which is negative 3. So the limit is negative 3. All right, moving on to example B. Similar, always start with direct substitution. When I plug in a negative 2, I get negative 4 plus 4. And when I plug in a negative 2, I get 4 plus 12 minus 16, which is 0 over 0. That is indeterminate. That tells me 0 over 0 always means that there's a hole. So we need to cancel out that hole. And in fact, the hole is always going to be wherever that thing is. All right, so this will be the same as the limit as x approaches negative 2. I can factor out a 2 on top. And the bottom factors out to be, I know there's got to be an x plus 2 because there's got to be a hole there. And then the rest is x minus 8. I can cancel out or remove that hole, which means that I have the same limit as 2 over x minus 8. I'm going to try direct substitution again, and I'm going to get 2 over negative 10, or negative 1/5, and that is the limit. All right, I'll let you guys go ahead and pause the video here to work on examples C and D. All right, I'm assuming you guys have finished working on those examples. Here's example C, same idea. When you plug in a 0, you get 0 divided by 0, which is obviously a hole. So you factor, and you end up with x over x plus 3. Try direct substitution, and you get 0 divided by 3. Now, a lot of people make the mistake here of thinking that that's still not an answer, but 0 divided by 3 or 0 divided by any number is still 0. So my limit is 0. In example D, similar idea, plug in a 1, I end up with 0 divided by 0, so there's a hole there. Plug in factor, I can cancel out the x minus 1s, and then when I try direct substitution again, I get 1